place. But today we're going to be focusing on issues that affect all of us, no matter where we live, because we're all residents of the same house here. So first, Dr. Lynn Comisky will be speaking to us about weapons of mass destruction and global climate change. And then Dr. Katrina Nielson will be talking to us about changing seascapes with a particular focus on overfishing. And just to point out in the back, Dr. Nielson brought in a couple of things that might be of interest. The Monterey Bay Aquarium Seafood Watch, which is a great list of what to choose when you're shopping for your fish dinners, what not to choose. And a brochure about, and I wasn't all that familiar with this one before, CCOR, which is California State University Center for Integrative Coastal Observation, Research, and Education. So we're one of a number of CSU campuses that do some applied coastal research. So if you want to pick one of those up on your way out, feel free to do so. So anyway, please begin when you're ready.
Am I supposed to use the mic for the...
You can use the mic if you wish. Sure. Go ahead and pick it up if you like.
Yeah.
Well, I mean for the taping.
Do you need it?
Well, it's for because they're taping it.
That's right.
There you go.
All right, this is going to be really challenging because I don't have enough hands. Hi, I'm Lynn Comisky, and I'm the chair of the Physics and Astronomy Department, and normally I talk about black holes and things from outer space, but as one of my sort of passions, I like to educate people about weapons of mass destruction, and so every year I give a lecture called The Physics of Weapons of Mass Destruction. That's in the War and Peace Seminar Series, so if you want to learn more, come to that next fall. This is a short version of sort of a related topic, and I'm going to tell you the good news. The scientists have figured out a way to combat global warming. The bad news is it takes a whole bunch of nuclear weapons going off. So that's what this talk is going to be about. Okay, so I'm just going to tell you a little bit basic stuff about nuclear weapons to start with, and what they do, and then we'll talk about regional nuclear conflicts and the era of terrorism and what that does. And there's some little people watching something blow up and thinking, my gosh, what an advanced society. Okay, so going back to the real nuclear weapons that were actually exploded in Hiroshima and Nagasaki in 1945 during World War II, each one of these weapons was approximately 15 kilotons, which means 15,000 tons of equivalent of TNT or dynamite kind of chemical explosive. And it only takes about 2 pounds of uranium or plutonium to make that big of an explosion. That's basically the size of that water bottle there. So these kind of weapons are small by today's standards. In the US and in the Soviet Union or Russia, conventional warheads are usually 10 times that big. Nevertheless, an explosion that's the size of Hiroshima burned about 13 square kilometers. There's a picture of the actual mushroom cloud. There's a picture of what was left in Hiroshima after the bomb went off, just a small part of the city. And you can see it's pretty much obliterated. And as far as who has the nuclear weapons around the world, this is in millions of tons, megatons. The US has about 1,800 million tons worth of nuclear explosives. This is after they decommissioned a lot of the weapons as a result of the SALT II treaty. Russia and the US both have a lot less nuclear weapons than they used to have. China also, France, UK, those are the confirmed big 5 countries that have a lot of weapons. And there are a lot of other countries that have tests, and that includes Israel and India and Pakistan and North Korea, of course, most recently. But this is sort of the historical picture of who has them and who are the people that are actively developing things. The real truth is that there are a lot more countries, actually up to 45 countries in the world today, that have the potential to make nuclear weapons. And that's because they have power plants that are enriching uranium or manufacturing plutonium that can be diverted from the use in the power plants to make nuclear weapons out of. And this is an estimate based on the power plants in these countries how many Hiroshima-sized weapons they have the materials to make. Of course, just having the materials doesn't mean that you're making weapons, but it means that you could if you wanted to. So it takes national will as well. And of course, North Korea, for one, has the national will, and Iran may be another place. They are actively enriching uranium right now. So these are other countries who have said in the past that they want weapons. Here are some countries that used to have weapons and don't have them anymore. They've actually decommissioned their weapons and have gone public saying that they don't want weapons. And Belarus, Ukraine, and Kazakhstan were all parts of the former Soviet Union, and they had Soviet Union weapons, and they got rid of them when they became their own countries. So that's one slightly positive note. Iraq, of course, used to be on the wanting weapons list. Now the country is so fragmented that it's hard to say what they might want, or if they're really a country. Okay, so this is an interesting thing. You can try this out. I have the link at the end, but it's easier just to Google nuclear weapons effects calculator, and you'll get this little Java applet that comes up. And what it shows you, you can pick your size of weapon, and you can pick your city, and San Francisco, which is shown here, is one of them. And it shows you what the impact is on a given city for a delivery either by automobile or airplane of a specific size weapon. So you see there's a blue circle and a red circle and then a yellowish circle. The red circle is the thermal circle. Within that region, you'll have a total firestorm, and widespread fires will pretty much demolish everything. The blue and the yellow circles are the pressure blast waves. So as the firestorm burns, you get this big shock wave that goes out through the city and knocks some of the buildings. The blue circle destroys pretty much everything, and the yellow circle has moderate damage. Now I'll back up now that you know what the circles are, so you can see it again. So here's the blue circle. You know, everything is knocked down and burned within that area, and here's the moderate damage area. And this is for automobile deliveries, so it's on the ground level. If you have the same size bomb, this is a Hiroshima type bomb again, that you would deliver by an airplane so that it's above the ground, you can see the damage is far more widespread. And just to show you what kinds of lingering effects you can have, this is a map of the region in the former Soviet Union near Chernobyl. And here's where the plant was. And this wasn't even a bomb, right? This was just the world's worst nuclear accident. And this shows the contaminated areas with the leftover radiation that is preventing people from living in them. Here's the scale in here, 100 kilometers. So here's the Chernobyl plant. All this dark red is the confiscated and closed zone. No one's allowed to live there. The slightly less dark red is the permanent control zone. Then there's the periodic control zone, and then there's other zones that they're watching. And what happened was the air currents spread the radiation around, so it didn't stay confined to the vicinity of the plant in general. And this is many years later, right? I mean, this happened a long time ago. And still these areas are pretty much off limits because people that live there are just too affected by the radioactivity for it to be healthy for them or their children. Okay, so that was just sort of the background. What I really wanted to just spend the next few minutes talking about is some really interesting work that I learned about last December when I went to a press conference at the American Geophysical Union meeting, which is held every year in San Francisco. And these people, whose names I've sprinkled through here, were kind enough to send me some of their PowerPoint slides, and I've read some of their papers since then. But it's basically Toon, Robach, and Turco are the people that sent me their slides, and they're sort of the leaders in this field. And they worked together with Rome and Jensen to do extensive atmospheric modeling of what would happen in the event of a regional nuclear conflict. So we've pretty much moved away these days from the superpower showdown. You know, Russia or China are not likely to be launching any intercontinental ballistic missiles at us anymore. And so what we really are more worried about is some kind of limited nuclear conflict that would be a regional conflict. Whether it's caused by terrorists or whether it's caused by two countries that are mad at each other that both happen to have a few nukes, we're not likely to be facing the kind of global strategic battles that people were worried about, frankly, when I was growing up, and that shows you how old I am. So what these folks have done is a series of calculations trying to figure out what would happen if you had a regional nuclear conflict, and what they are modeling here is, say you have two nuclear powers that are mad at each other, like India and Pakistan, right next door to each other, and they each send about 50 Hiroshima-sized bombs at each other's largest cities. Then what would happen? Well, about 5 million people would die right away, and eventually you'd have as many fatalities as you previously expected for an all-out strategic war between the superpowers. But what was sort of unexpected in this work is that they found out that the deaths that you would get in these megacities, because the world is far more populated now, and really, really big cities exist that are very densely populated with people and things that burn, is that you get deaths per kiloton of weapon that are about 100 times greater than you used to calculate when people were doing this modeling for strategic nuclear conflicts. So let me show you some of the pictures after this. But the bottom line is that as a result of this megacities burning, you get all this really dark soot that rises up into the atmosphere. And it's very black because of all the combustibles in the cities compared to what there used to be. And that soot gets up into the upper troposphere and spreads all around the whole world. And so it isn't quite a nuclear winter like they used to be predicting, where the temperatures would drop by 30 or 40 degrees, but it's enough to make the temperatures drop by more than 1 degree for over a decade, as well as creating big holes in the ozone layer. So you've got two really bad things going on that have significant environmental impacts in terms of the growing season, the crops, and disrupting the food supply. So here's an example of combustible material in cities. This is a square kilometer of Bangalore, India, which is actually only 47th on the world's biggest city list. San Francisco's 36th, in fact, in terms of population density. And compared to, say, the suburb of Nashville, Tennessee. And each one of these images is only 1 square kilometer, which is, you know, there were 13 square kilometers destroyed in Hiroshima for one bomb. They also have found out that each person that lives in a megacity, when that megacity is incinerated, creates about 11 tons of things that burn per person. They actually calculated all the different things in the cities that can burn, and they have extensive tables in the papers that you can look at if you're interested in learning about this more. So here's a map of what happens to the soot that spreads from this limited nuclear exchange. And the little numbers show you how much percentage of the sunlight is getting through. As a function of time, you can see the days clicking by. It just takes a few days before the incinerated soot cloud spreads all over the whole world. And basically lowers the sunlight by around 10% ultimately everywhere as they keep running the model. There are two effects going on. The soot is really dark, and so it absorbs the light coming in and keeps the sunlight from getting down to the ground, but also that heats up the soot as it absorbs the light and makes it go up to the upper levels of the atmosphere from which it can circulate around the whole world. This is sort of an anti-greenhouse effect. So see, here's the smoke layer, and here's the sun coming down and not getting to the ground, or just a little bit of it. And then the warmth from the ground just manages to get out through the smoke. So sort of the opposite of global warming, hence my crack about global cooling earlier. And this is what's expected to happen to the global temperature. So here we are now at 0, and it goes down by somewhere between 1 1/4 and 1.5 degrees, and takes about 10 years to recover. Now, they've been able to verify all this modeling by comparing their programs that do all this modeling to what happens when a big volcano goes off. some of you may remember Mount Pinatubo going off a few years ago. That actually created global cooling that lasted for a few years. If you look really carefully at the graphs and the inconvenient truth or whatever, you can actually see that effect. And a volcano is a whole lot less soot than the stuff that would be created by incinerating populated cities. And also, it's not as dark of a color of soot, so it has a lot less effect overall. And here is a map of what happens to the growing season in the two different hemispheres. And so you can see that the growing season gets shorter by, tens of days in most of the world. And that makes it very difficult to raise the kind of crops that we need to feed the population. Also, there's less evaporation from the oceans, which means there's less rainfall, which means there's a drought, which means that that's even harder to grow food. So you've got no water and a shorter growing season, which, considering that the world is pretty precariously balanced in terms of global food supply, is a very bad effect. So anyway, to summarize, in conclusion, we have nuclear weapons capabilities, if not the intent, that are spreading throughout the world despite our best efforts at non-proliferation treaties. And I think these people have put together a fairly convincing case that even a so-called small regional nuclear war can have catastrophic consequences that would affect the whole globe. So let's stop nuclear proliferation and let's try to control the materials that people can make things out of. It would be good if our country actually took the lead in trying to do this instead of the opposite, which has been what's been happening during the current administration. Here's some resources that you might want to look at to learn more about it. This is one of the two papers that I recommend that you look at, and I'm going to post this talk online, so if you Google me afterwards and you go to my homepage and click on presentations, you'll find this whole talk. Since I didn't have it together enough to do handouts like Dr. Nielson, and that's the other paper that I recommend that you look at. And then here's if you don't want to Google nuclear weapons effect calculator, that's the actual link, but it's a lot harder to remember. Anyway, thank you. I guess, do we have questions now? We're at the end, or what do you want to do? Okay. Alrighty. Well, we'll just switch the computer over here and switch speakers.
Hi there. How many of you like to eat salmon? Show of hands. Oh yeah, everybody likes to eat salmon. I read the newspaper yesterday. I actually had a moment to look at it, and I just want to start with a quote from the San Francisco Chronicle food section. Today, fishing boats are streaming from California harbors for the first salmon catch of the season, and since 2005. For 3 weeks, until May 31st, the waters closest to San Francisco, from Point Arena in the north to Pigeon Point in southern San Mateo County, are open to commercial fishing of wild king salmon. Finally, we can eat. But the cheers and consumption, experts say, will be short-lived. That's because the area will be closed for the entire month of June, the most abundant month for local salmon, in an attempt to preserve enough fish. That's just one species for which, obviously, we know there are major problems. And what I'm going to be talking to you today about are shifting seascapes and the problem of overfishing. My talk is going to be divided into two parts. First is going to be the doom and gloom, which maps on nicely to what Lynn just gave us, but there is a hopeful note at the end. I hope to show you some of the evidence for overfishing and the global crisis of overfishing, and that the evidence is inescapable, and then tell you a little bit about how we might be able to proceed to save our seas and how we could have our fish and eat them too. Okay. In 1998, Daniel Pauly, who's a fisheries biologist up at the University of British Columbia, published a paper that basically concluded that we are fishing down the marine food web. What does this mean? This is a depiction of the main conclusion from his paper. When we start fishing, we go for the biggest fish we can get. That's what you like to get. It's easy. You get one big fish. You clean it, you eat it. You've got a lot of food. Well, if you keep doing that, eventually there are fewer and fewer big fish in the sea. And you start fishing smaller fish. And you start fishing down the food chain. That means that you're not only fishing smaller fish, but instead of fishing top predators, all of a sudden you're fishing herbivores and lower trophic level fish. So big shifts in ecosystems. And Dr. Pauly predicted that instead of having swordfish on our tables 100 years from now, we would only be able to have jellyfish. It's a pretty dramatic prediction, but in fact, perhaps not too far from reality. And one of the problems with having jellyfish left is that they are major predators of larvae and juvenile fish. So if you're trying to restore your fish and populations and you stop fishing for them, but you fish down the food chain so that you only have these guys left, they may eat all the babies. So that's kind of a problem. Let's look at some of the evidence. There have been a variety of pieces of evidence for overfishing that have come to the forefront in recent years from using a variety of different tools. Because it's very hard to know how many fish there were before we started fishing, because most of our fishing records come once we've started fishing and realized, oh, there's kind of a problem, maybe we should start counting them. So one of the tools that people have used are genetic techniques to estimate prior population sizes. And this was a study done by Steve Plumby and his colleague Joe Roman at Stanford University, and they used genetic data to estimate the historic abundance of whales before whaling. So this is population estimates from the genetic information. You can see they're substantially larger than the current estimates of those populations. So those are for 3 groups of whales in the North Atlantic. Very recently, Ransom Myers and Boris Verm from Dalhousie University did a massive analysis of fisheries data from the Japanese fishing fleet from the longline fishery, and looked at the abundance of large predatory fishes, things like marlin, swordfish, tuna, and looked across many different regions in the world's ocean. And the only thing you really need to take home from this is that from 1960 on to about 2000, you can see that for almost every region they looked at, there's been an exponential decline in the abundance of these fishes. Every single fishery. And if you want to get a sense of how this happens, this is a map over time of the number of fish caught per 100 hooks put out in the Japanese longline fishery, and 1952, 58, 64, 1980, and the hot areas represent areas of high catch, more than 10 or more per 100 hooks soaked. And the blue areas represent declining returns, if you will. And you can see that the fishery is going further and further afield, finding fewer and fewer fishes close to home, and eventually depleting stocks again. So increasing fishing effort, having to go further home, resulting in fewer fishes. Now, the loss of these top predators is not just important in that we lose the predators, but they have these cascading effects down the food chain, which are incredibly important. Ransom Myers also did a study which was published just recently in Science on the impacts of how the loss of predators affects and transforms ecosystems. And this is in, again, the Atlantic coast on the east coast of the U.S., looking at what the decline in great sharks has precipitated for that ecosystem. And the main message from this is that sharks, which great sharks, large predators, eat smaller predators, impact their abundance. When these decline, and notice all the lines are going down, this is over time, 1960 to 1990 time frame, skates and rays increase. Skates and rays, particularly the cownose ray, feeds on scallops. Scallops initially, there's a fishery for them. It goes up, and then it crashes. Okay, so we have great impacts on ecosystems, not just on the species we're fishing for. We've gotten really, really, really good at finding fish. We've gone from small-scale fisheries to wholesale industrialized fisheries. We know how to find the very last fish left if we want to. We also are very wasteful. In many fishing practices, we may want to fish for shrimp, and we get a lot of bycatch, species that are not commercially useful, and the only thing we really want are the shrimp, and we toss what we don't want back into the ocean, for the most part, dead or in a condition such that they're unlikely to survive. And it's gotten to the point where we're actually starting to ranch large predators, like tuna, sea ranch them. And what does that mean? Well, you go out into the wild, you catch the last few tuna you can find them in a pen, and then you go fish for lower trophic level fishes that they feed on, so smaller fishes. So then you go and deplete their prey, and you put them in the tanks with them, and you fatten up these fish and you sell them. So that's another problem with ranching. It's evidence of our increasing impacts on the oceans. And just to bring it back home a little bit, this is something that obviously impacts, as I just talked about, the salmon. Rockfish on the west coast have also suffered similar declines. These are just several species here of rockfish. This would be their abundance, estimated abundance in an unfished state, and then what their declines have been through time. And this is the threshold that the National Marine Fisheries Service defines as when a fish stock is overfished. It's at 25% of its pristine biomass, and you can see that most of them have reached that point. Those aren't the only species that we've had good luck at impacting on the west coast here. I don't know how many of you are familiar with the sea cow. Anybody ever heard of the sea cow? It's a big, large, manatee-like organism that is completely extinct. When Europeans came over, it used to graze on kelp, particularly in the northern part of the eastern Pacific. And they were easy to hunt, and we drove them completely to extinction. The native oyster is not very prevalent anymore. Sea otters are absent in much of their historic range still, and abalone have been severely depleted as well. And abalone is a nice example. It's local. It's something that a lot of people are involved in terms of sport recreational fishing. And this is another species in which we've seen huge declines. These are the abundance of abalone landed or brought in from California Department of Fish and Game records from 1916 all the way out till 1997 when the commercial fishery was closed. And you can see that this fishery has grown, grown, grown. There's a big drop over here. Anybody know what that's from? Any ideas? World War II. And this was primarily driven by Japanese fishermen, and they were interned at this point in time, and that dropped the abundances there, so that's kind of interesting. Picked up again afterwards, and then declined once again. Well, we used to have plenty of abalone. We like to eat abalone, and now we're culturing abalone. And those are the only kind of abalone you can purchase now, are cultured abalone. And there's very, very severe restrictions. You can only free dive for abalone north of San Francisco now in recreational. And very limited the numbers you can take. Well, it's not just that abalone have declined, because this is all abalone. Abalone represents a complex of several species. It's not just one species. So as it turns out, we have done what is called serial depletion of this fishery. We didn't really pay attention to the fact that there were multiple species in the fishery. And so first we started with the reds, then the pinks, then the greens, then the whites, then the blacks. And as we started to get declining returns in some of the more abundant species, we pick up the other ones, the other ones, the other ones, and it gives the appearance. Notice in the prior graph, it looked like it was stable across here. So we were filling in with other species, but in fact, we were decimating one species after another, and that wasn't apparent at first. Okay, so doom and gloom, results of the global overfishing experiment, as I like to call it. I think the main things that are inescapable are that the population sizes of fishes in the ocean and other marine resources are decreasing. One thing I haven't been able to show you data for yet, but that accompanies this is that the average size of species declines as they are exploited, and there are major shifts in the ecosystems that cascade as a result of this level of exploitation. And the take-home message really is that fisheries management, business as usual, is clearly not working. And this is not important just because you want to eat salmon or abalone. If you look worldwide at how fisheries sustain people in other places, worldwide about 1 billion people are sustained by fish, and many of them on a subsistence level. So this has the potential to really have an impact of global proportions. Now, you're probably wondering why I have a picture here of this primate. Well, there was an article in National Geographic about 2 months ago, and I recommend if those of you are interested in this topic, you go look at the back issue. It's on the internet. It's pretty interesting. They basically are starting to think that this increase in exploitation of bushmeat, as it's called in Africa, is perhaps a consequence of declining abundance of fish. So sort of an interesting effect, unexpected. All right, that's the gloom and doom. Let's think a little bit about how we might save our seas, how to have our fish and eat them too, because scientists have been working on this for a long time, and some of us think we have some ideas about what we might be able to do. And I'd like to talk to you today about 2 important tools. These aren't the only tools, but these are 2 that I think are worth thinking about. Marine reserves and consumer choices. We'll start with marine reserves. There have been a number of studies on marine reserves. One of the things you need to know about marine reserves, and what I mean by marine reserves are fully protected marine reserves. No fishing, no drilling for oil, no pollution, complete protection of all species. Okay? How many of you have heard of national marine sanctuaries? Most of you. How many of you think you can fish in a national marine sanctuary? You would be wrong. You can fish, commercial fishing. The only thing that national marine sanctuaries protect are disturbances to the seabed, so drilling for oil. That's not to say it's not good. It's great. It's a little bit of a misnomer, though, because it's not really a sanctuary for marine life, other than protecting them from the potential for an oil spill. Okay, so truly protected, fully protected marine reserves are very far and few between. Less than 1% of the world's oceans are found in marine reserves. Okay? And one place that is a marine reserve that some of you may have had a chance to visit, postage stamp sized marine reserve is out at Bodega Head at the Bodega Marine Lab. The area right around the Marine Lab is a marine reserve. All right, so what kinds of changes can we see when we put an area into reserve and prevent people from coming in and fishing? Well, the effects are dramatic. They don't take very long to occur, and they are long-lasting. And what we see is that when we put an area into reserve, we see approximately a 400% increase in the biomass of most animals. We see approximately a 200% increase in the density of those animals. We see an 82% increase in the average size of animals, and approximately a 71% increase in the diversity of organisms in marine reserves. So very positive effects. Just as an example, to give you a visual of what that change in size might look like, these are scallops from inside and outside of a closure in the Georges Bank from the cod fishery when they closed it to trawling. This is what happened to the change in the size of scallops. They got enormous. And those big, fat animals produce lots and lots and lots of eggs, lots of babies, that actually end up being really important for effects that we may see outside the marine reserve. Now, I alluded to the fact that they produce a lot of eggs, and many marine organisms have what we call open populations, and they have dispersal phases. So larvae, juveniles, don't use necessarily the same habitat as adults. This is a depiction of organism that has adult habitat over here in very deep water. They spawn eggs and sperm, fertilized eggs grow into larvae. The larvae get moved around by ocean currents. They have a habitat where they spend the juvenile portion of their life, and then they return to an adult habitat. However, it is often not the same place where their parents lived. Okay? That's an important aspect. So dispersal is a very important feature of most marine organisms, but they don't all disperse the same distances. And different groups disperse different distances away from home. Seaweeds, not that far. Invertebrates, like urchins and abalone and scallops, have a wide range of dispersal distances. Fishes tend to move further away from home habitat. All right, so if you were to put a marine reserve in one place and babies don't stay close to home, you kind of want to have some insurance that you might protect the babies somewhere else. So one of the ideas that has come up is the idea of putting in networks of marine reserves so that juvenile and adult populations are protected and that it provides for opportunities for organisms to disperse and actually be protected even if they leave the place, which might be a marine reserve where they were born. So the way I like to describe networks of marine reserves and how they work is that they're like putting away some capital and investment, and you end up having interest, organisms that leave, and you end up using that for your commercial exploitation or for eating, if you will. This is just a depiction of parent population and a shadow of how far the juveniles might go from the parent population. And this is an idea of putting in a couple of marine reserves, different locations, that would allow for dispersal among them. But notice that there are also areas outside where juveniles might go. Okay? So not everything is in a reserve. And having variation in the spacing, as I alluded to before, things travel different distances. So having things spaced at different intervals along the coastline might be an important consideration as well. And the reason for that is that you want to provide refuges for many different kinds of species. Typically within a reserve, and if this represents a reserve, species with very short dispersal distance will be retained. Diversity will increase, you'll get larger individuals. And so within a reserve, you can really meet conservation goals. As you add reserves, you are able to accommodate dispersal among them. And if we believe that climate change may impact the geographic range in which species occur, allowing for migration in response to climatic change would be a good thing. And we also allow for spillover outside the reserve. Spillover is a really important concept in terms of fisheries management. Okay, it's all very well and good if we have large, big, fat, happy animals inside a marine reserve, but if you can't fish them, then there's not much good for fisheries management. Well, it turns out that spillover is one of the really great effects we've seen in marine reserves that may actually help us manage fisheries. So let me explain what this spillover effect is. I showed you that the juveniles disperse outside of the parental habitat. And this is an example from Caribbean where about 35% of fishing area was placed into marine reserve, off limits to fishermen. And this is the abundance of the commercially exploited fish over here, over time. Over here represents the biomass that was available prior to putting in the reserves. And after here is the change, after they put about 35% of the fishing area into reserve. And the main thing that I want you to see is that the abundance of fish, these commercially important fish species, increases dramatically in both areas over time. This is in the region that is not being fished, and this is in the region that is being fished. So you get this effect of spillover. You also see much larger fish. And that's because fish that are able to grow up and get fat and happy within the reserve are actually able sometimes to swim out. So it's not just a spillover effect of the larvae, but it's the protection that they are afforded by being less susceptible to being fished. This is an example from Florida, Merritt Island, where it was effectively a reserve because it was off limits, because it was so close to where they were doing the space launches. And I had forgotten, that's a nice link.
I've been there.
Anyway, it turns out that if you look at the record size catches in all of Florida, so where are the biggest fish caught, and you look before 1985 and after 1985, when this was placed off limits, you'll see that before 1985 you had a lot of record fish being caught in the commercial and recreational fishing areas of Florida, and afterwards fewer. And in the Everglades National Park, the same thing. That's reflecting the overall decline in the sizes of fish. Okay? Within 100 kilometers of Merritt Island, you see the exact opposite effect. Okay? You get huge numbers of record-sized fish being caught adjacent to this marine reserve because of the spillover effect. All right. It is there. Oh, I have a little animation there I didn't realize. Okay. Let's bring it back home. Right now in California, we are lucky to be at the forefront of marine conservation efforts. The Marine Life Protection Action Initiative was instated into law in 1999. It mandates that California review the existing marine protected areas that exist, create a marine reserve network. It is a partnership, public-private partnership, and there will be, it is meant to be implemented on a local scale so that there's input from many, many people, scientists, resource managers, stakeholders, the general public, and it encourages the involvement of local fishermen. So this is great news. This is an example of a meeting that took place when they were trying to figure out where to place marine reserves in the central California coast. And you can see that people are getting down and dirty looking at maps, putting lines on maps, and trying to figure out where good spots would be. You can come up with a map that will show you areas that might be of special concern. This was one proposal for reserve areas in that region, based on how irreplaceable the habitat or resource was in that region. These are areas that fishermen stated they would be willing to give up fishing in. And in general, through planning processes like this, you can come up with many potential options for where to place marine reserves. This is an example from the Channel Islands. The nice thing about the planning process as it's operating now is that there are many options possible. Stakeholders are involved, and we can optimize reserve areas for many goals. This is the result of that Central California region planning. These various marine protected areas were approved just this year. There are 29 MPAs, or marine protected areas, with various levels of protection, 204 square miles. And we're just about to start planning for the North Central California region. That includes us, Sonoma, Mendocino, and San Mateo counties. And there are opportunities for you to get involved with that. I'll talk, the handout back there has a link to the page where you can find out about when the public input meetings are happening. The last tool I just want to touch on briefly is the role that consumer choices can play. There was a campaign a number of years ago to save Atlantic swordfish. It was called Give Swordfish a Break. And it was a very successful campaign. Many famous chefs, cruise lines, more chefs, stores, in 1998 started to agree to take swordfish off their menu because it was in very bad state. The demand for swordfish declined as a result. Congress called for action. The International Commission for the Conservation of Atlantic Tuna, National Marine Fisheries Service, they acted slowly, but they did respond eventually. And in 2000, the U.S. protected the swordfish nursery grounds. The campaign ended. And in 2002, Atlantic swordfish were declared 94% recovered. So you do have some power to make changes. And Monterey Bay Aquarium has Seafood Watch program. And I would recommend you go to their website to find more information. I've got some of the Seafood Watch wallet cards to help you make educated choices about which seafood to consume and which to avoid. And let's see, okay, they have some action cards which will tell you about which species are particularly imperiled and what the problems are. Lots of stuff on their webpage. Chilean sea bass is one that's particularly interesting. It is not recommended that you eat it, despite the fact that Whole Foods is now selling it.
It's farmed though. They're farming it. That's what I heard.
At any rate, these are, we can talk about that in a minute. The wallet cards, I've got some back there. And these are some links with more information about the science of marine reserves down here. This is a good place to go. Seafood Watch and the Marine Life Protection Act initiative and how it's being implemented. And I'd be happy to take any questions. No, Lynn is.
I thought I heard that Whole Foods was selling farmed Chilean sea bass, but I don't eat farmed fish,
no,
so maybe that wasn't really true.
It's not farmed. It is supported by the Marine Stewardship Council as being a sustainable fishery. But if you know anything about fish biology, these fish live to be 50 to 100 years old. It takes them 15 years to get to reproductive maturity. There's no way we should be having a commercial fishery for these fish. Bottom line.
Well, I'm glad I didn't start eating them.
It's fairly controversial right now. It's been in the news. So.
I have a question for Katrina. I like the information about the Marine Life Protection Act, and I've read some things about how they're doing certain sections of the coast at a time. But how is it decided who participates in that? You said it's public and private.
Oh, yeah, it's a public-private partnership, and Lynn was asking how it's decided who participates. Basically, they have public meetings where people are invited, so the general public can come and provide input. They seek nominations for people to serve on stakeholder groups and on scientific advisory board. So there is a process where nominations are sought, and they have seats for representatives of environmental groups, fishing groups, people on the Fisheries Management Council, people in commercial fisheries, a variety of different stakeholders, as well as scientists. And right now they're in the process of deciding who's going to be on the Science Advisory Board.
And then just a related question to that, is there a specific number of reserves that are required by that act, or is it?
No.
No.
Question for Lynn.
Okay, Phil?
Yes. Under the current related treaties that Russia, France, China, US, and Vietnam, what kind of nuclear activity you are still allowed?
Oh, okay. He's asking what are the current treaties govern in terms of nuclear proliferation. And there is a treaty, and when I give my longer talk, I have time to talk about them. But the Nuclear Non-Proliferation Treaty basically is signed by something like 175 different countries, and they all agree that if the Big Five, the US, Russia, China, UK, France, will stop their vertical proliferation, that the other 170 countries will not contribute to horizontal proliferation, which means they won't spread making nukes through the other countries. So the problem is that the Big Five have to stop the vertical proliferation, which means they have to stop making new kinds of weapons, and they have to stop manufacturing weapons. And for a long time, before this current administration, the US had in fact stopped making new weapons and was taking down the stockpiles and destroying weapons under the SALT Treaty, which is the Strategic Arms Limitation Treaty with Russia, well, the USSR at that time. And so things were headed in the right direction. But since Bush got elected president, he has actually been increasing money for development of new generations of weapons, including things like the bunker buster weapons that are things that are designed to burrow into the ground and try to find hidden underground, places where other armies might be and blow them up, including lots of dirt, which then gets thrown up into the air and becomes radioactive, and it just makes a terrible mess. And he wants new generations of strategic weapons and basically, anything they can think of that they can spend money on for more militarization. So the other countries who
expect us to keep our end of the deal have been fairly disenchanted by the fact that the U.S. has gone willy-nilly into breaking our part of the deal. And so a lot of the other countries have either withdrawn from the Nuclear Non-Proliferation Treaty, such as North Korea, or just are ignoring it, such as Iran, have gone about enriching uranium. So, that's sort of in a nutshell where we stand with the treaties. And the SALT II treaty, which was the second version of the Strategic Arms Limitation Treaty, which was signed by President Clinton, was never ratified by the Republican Congress at that time. So that basically no treaties since then have gone forward and have been ratified by the U.S., and without the U.S. ratifying them, they don't hold force in the world.
That's too bad. And Russia can do the same thing like the United States.
Right. I mean, once the major powers back away from the treaty that they have signed and ratified, such as the Nuclear Non-Proliferation Treaty, then the rest of the countries really don't feel it applies to them. Now that treaty is re-ratified every 5 years. So it came up again most recently in 2005, and again all the have-not countries complained, you guys are breaking your word, and the U.S. response to that was, oh yeah, so what? So the only solution for that obviously is to elect people to control this government who actually take nuclear weapons seriously and will obey the treaties that they have agreed to and continue to cut back on the nukes. We have, it only takes a handful, as you see, to pretty much destroy the world. So considering that we have, thousands of handfuls, there's really far too many nukes out there in general.
Sort of related to that, I was on an airplane recently sitting next to there was a lawyer there representing, I think, waste management companies. And she was, got in a conversation, she was suggesting that solar power energies are just not cost effective compared to nuclear technology. And I don't fully understand all of that.
Okay, so the question is about solar energy versus nuclear energy.
Is nuclear, when you talk about nuclear proliferation, does it also include nuclear energies for other uses?
Right, and so how does that what does that have to do with power plants? This is a really complicated question, and it depends on how one calculates cost, right? There's only a certain amount of sunshine that falls on any square meter of ground. In fact, it's enough to produce 1,420 watts. Okay, so that's 1.4 kilowatts, so that's 1,400 watt light bulbs. Okay, clearly, and that's, this much ground, right? So the size that your refrigerator takes up can run a few hundred light bulbs. If you had 100% efficient solar panels, they're only 10% efficient, maybe 20. So okay, you get 10 or 20 light bulbs. But that's not enough energy to run that refrigerator that's sitting on that square meter of ground. So if you have widely dispersed solar power, and don't forget it takes chemicals to make those solar cells, and that takes mining, and that takes silicon, and things like that. You've decentralized your power grid, and you're not doing things very efficiently. Nuclear power is totally at the other extreme in terms of all the possible choices for power that you have. You have monstrous power plants, they're sitting there, they're very concentrated, you get a lot of power out of them, but they also have extreme environmental effects because this country for the past 20 years has been trying to figure out what to do with the nuclear waste that comes out of the power plants that we have, and we still haven't come up with a good solution. The people in Nevada don't want us to bury all the waste under Yucca Mountain, but still that's the best solution we've come up with, and it's still not happening. So right now, all the power plants still just store their waste on site at the power plant because they're not allowed to take them off site, and they're not allowed to send them anywhere. So that makes a mess of a different sort. And so yes, nuclear power plants are more efficient because you can get a lot more power out of a certain size that they sit on the ground compared to solar power or wind power or any of the widely dispersed powers. But they have incredible environmental consequences. The one thing they don't do is make greenhouse gases. Okay, so there are pros and cons in all of these different things, and it just sort of depends which thing you're the most worried about at any given time, what you would opt for. The only really safe thing to opt for is conservation, because that has the least impacts on anything.
Well, given that James Hansen says that we have 9 years to avoid essentially catastrophe, to avoid 450 parts per million carbon dioxide in the atmosphere, where they think now is the tipping point. We used to think it was 550, which essentially means a 2 centimeter rise in temperature. And are you aware of any risk analysis globally, or can you give one, of an outcome of comparison between the two technologies that provide power 24/7, 365 that people are talking about, coal and nukes? And
well, it's certainly true that burning coal creates more hydrocarbons, and that contributes to the carbon load and to the greenhouse gases. And I mean, as I said, that's the one thing that nuclear power has going for it, is that it doesn't contribute to the greenhouse gas problem. And James Hansen is a very esteemed NASA climatologist and earth science person who's done a lot of the global warming work and been very outspoken about it. I think it's pretty clear that the tipping point cannot be predicted exactly, but it's gotten pretty darn close. And the rapid melting of the Arctic ice shelf is the most recent news that I've been reading about. The less ice you have, the less light gets reflected, the more heat gets absorbed, and the faster things melt. And so you get into these really, really awful positive feedback things, just like with the fisheries. And the big ones go away, and then the littler ones start to go away. Once you get involved in these positive feedback loops where the things just spiral out of control, it's really very hard to stop it compared to if you would have caught it at the beginning before the whole thing exponentiated. Mm-hmm. And so, I don't really have very good solutions for this. I'm not an environmental scientist by trade. I'm really an astronomer, and the nuclear weapons thing is just sort of one of my hobbies. But I do read a lot about these things, and I'm afraid I don't have any very good answers for what we should be doing. We had a whole series of talks in the physics and astronomy department last semester as part of our What Physicists Do series, where we had a nuclear weapons a nuclear power person come and talk, and we had a solar power person come and talk, and we had people from all the different kinds of energy sources come and talk about the physics behind the different technologies and what the impacts were, and it was a very interesting discussion. Good thing to try to learn more about.
Question about it.
Yes.
Is there, really as you showed really rapidly, that a nuclear weapon can really change the content or the temperature of the ocean, and that's the content of it, the way we relate to it. Is there something that happens, understanding that everything's connected, of course, that when the ecosystems of different fishes, marine life is affected, that the environment, the ocean itself changes?
So is there an environmental component to some of the fluctuations? And yes, absolutely.
Not just the, like the changing sunlight, but within, like, if a species dies out, or is, on the decline, does that impact the environment of the ocean itself?
Okay, so if we lose species, does it change some other property of the ocean ecosystem? Well, that's an interesting question, and I would have to say that it certainly can in some cases. For example, you know how we have eutrophication being the high nutrient pollution in a lot of bays and estuaries that result in algal blooms, for example. Does that, you've potentially heard of that? So one of the theories was that was primarily caused by fertilizer runoff from agriculture, which certainly contributes. Nutrients fertilize those waters, and the phytoplankton, the algae bloom. One of the historical studies that was done recently to look at this problem said, well, actually it's not all that we're putting in fertilizer. It's actually that all the organisms that used to eat all that algae have been decimated, and those would be the oysters. And the oysters are no longer performing their filtering function. So yeah, there are these, and that changes, the amount of algae in the water column, changes how much light is reaching the bottom of the ocean. So there's all kinds of potential cascading effects just into of sort of what you're alluding to, I believe.
country has how many nuclear weapons. Where do you get those figures? Is there some sort of registry?
The references that I had at the end of my slides, the Federation, the two really good websites are the Federation of American Scientists and the Carnegie Endowment for International Peace. So those two websites have extensive documentation of, you know, which countries have what kinds of nukes and how many megatons and what kind of plants they're building to enrich uranium and things like that.
But there's no protocol for reporting it, that's just investigative?
There's no. I mean, it's just things that they figured out, the experts that go around to those countries. There is, of course, the International Atomic Energy Agency, and it goes around and inspects all the nuclear plants for the countries that have signed up to be part of that non-proliferation treaty. And so they have a handle on, you know, what they're allowed to see, but what we've discovered is that the countries that are the most dangerous have not signed the treaties, and so they don't allow inspectors. The countries that decide they want to become dangerous, like North Korea, pull out of the treaty, even though they had signed it many years ago. They pulled out of the nuclear non-proliferation treaty after Bush accused them of being part of this axis of evil. So then they just said, okay, we're not doing that treaty anymore. We renounce our signature, and we're going to start building nukes. So the treaties are only binding to mostly to the countries that are not a danger.
Well, if we could have a little conversation here. I've been involved in the environment and the energy field since the 1970s, when there were a number of us in the West who were concerned about India and Pakistan getting the technology for bombs from the peaceful technology they got from the United States and Canada. So we did what were called nuclear safeguards initiatives in 6 Western states, including California. I led the effort in Arizona. We lost them all, but we kind of changed the public discussion. I don't think people in those states, at least, believed any longer that there wasn't a connection between the bomb atom and the peaceful atom. And that, you know, the propaganda coming out of Washington was, the Atomic Energy Commission, was that nukes would be too cheap to meter. Well, we know that's not true either. And a number of other things. Now I think coal is more of a problem than nukes. I'm not, you know, a believer in nukes either.
From the point of view of global warming, it's pretty clear that coal is a more immediate danger.
But it seems like we're too comfortable in the U.S. to deal with either of these problems. And I would suggest Norway. Gro Brundtland, the former Prime Minister of Norway, who's been a leader in the international area in these areas, was on Amy Goodman's show yesterday. And Norway has been voted the best country to live in for 6 straight years by the UN Development Association. We use 2.5 times as much energy per person as Norway does. And they've been willing, even though they've had a lot of oil from the North Sea for the last 50 years, to tax that very highly, both with a carbon tax and with a gasoline tax. They've also been willing to tax their 100% hydro very highly. So, and they're willing essentially to be completely carbon-free by 2050, not just an 80% reduction, but carbon-free. And they show that you can live a good life and still be much lower on the energy, quote-unquote. And it's a question of political will.
I agree, absolutely.
And unfortunately, we don't have much of that in the United States.
Not at the current time.
It's not a question of technology. I don't think humankind can expect to be blessed with another fuel like oil, especially, which is uniquely energy dense. But on its good side. On its bad side, of course, it contributes to global warming.
That's a good commentary. I think in terms of the time we have here, we might want to stop at this point, let these ladies finish up their things and maybe have a conversation after. But I think I'd like to thank everybody for the presentation. It was really very interesting, very useful information for all of us to have.
And please feel free to send me email if you have any further questions or stop by and visit.